Hi, my name's Stuart Marshall, and in this video I'm going to talk a little bit about digital transformation, specifically around capturing knowledge and how this might be applied in an engineering environment. So when we talk about digital knowledge capture, what are the different steps to get to that point of digital transformation? So in engineering companies, we accumulate lots of knowledge and experience over the years, and generally it's specific to the engineering company's field of expertise. And this knowledge is typically captured in documents, spreadsheets, even code, and even in experienced engineers' brains. And that data can be scattered um, all over the place in different formats and hard to find and interpret. So that's why the first step in digital transformation has to be discovery. So we need to find out all of the data that contributes to a successful project, from design to manufacturing and assembly, all the different areas. And we want to digitalize that so we can use it in a more robust way. So the next step is digitalization of that data. Now, this could be a central database that can be easily accessed by the engineering team, or the automation of design rules and workflows that would traditionally be done manually by the engineers. And this frees up resource to focus on the design work that really adds value to the projects. Once you've digitalized your data and some of your processes, the benefits can then be realized, and we'll touch on this a little bit later in the video. But then on top of them benefits, the digitalization opens up the possibility to further improve the end-to-end process by making better decisions through maybe the use of AI and machine learning models, optimization, and even process improvement initiatives like model-based definition or model-based systems engineering. So how can this be applied in the real world? So in this demo, I'm going to show an example of how we've captured some engineering knowledge and used that to automate the design decisions by leveraging NXOpen within Siemens NX. At this point, I'd like to stress that we've used NX for this demo, but the same approach can be implemented for any other CAD package. And you could even create lightweight versions of this to be used outside of the CAD environment if preferred. So let's kick off the demo. Okay, so I've fired up an assembly in NX, and for this example, we're going to focus on a generic problem of selecting bolts and a bolt and nut combination to join these two components together, and then we're going to create the correct holes for that bolt selection. That said, this approach could be applied to any well-defined design process where, the size, shape, or function of a design or a feature changes depending on the specific requirements for that project. This could also include analysis, but for this demo, we're focusing on geometry. So you can see in my view here, I've got a set of tools that we've created. We're going to focus on the bolt selector one, but we've got some other examples here where we're selecting standard parts basically. So we've got dowels, rivets, maybe helicoils, spigots. But as I said before, this could be applied to any well-defined design process that your company uses. So I want to join these two components together. I'm going to click on the bolt selector. Now we have a load of design decisions that are going to go into this bolt selection, and we're going to run through a few of these. This is not the complete list. Potentially, there could be some more considerations that you have, but for this demo, we've selected a subset. So we're going to say we want a metric bolt. We're going to select the two bodies that we want to bolt together. We've got a tolerance on the two flange faces for the thickness. We're going to set that at 0.4. We've got an engagement method for the thread. So typically we need to sized the length of the bolts so that enough of the thread is poking through the nut. This can be done on a bolt diameter factor or a min number of threads that are protruding through the nut. So we're going to select that, and we want a factor of 1.5 threads sticking through the nut. There's going to be some load on this joint, and you could imagine having a shear load where these are rotating, or an axial load. So we're going to select axial for this one, and we're going to set this at 500 newtons. And then we've got a bolt, nut and washer configuration that we want to select. So you could say any if you're not that fussed, or you could select a specific arrangement. So we're going to say we want a bolt and a nut with some washers. Now, when I hit calculate, what that's going to do is go and get all the data from the specs that you would need to use to size and select these bolts, and give us some options. So there's a bit of a history of what this is doing here. So it's selected, it's got the material from the bodies. It's looking in some databases for specs. We're calculating some max thicknesses of the flange and some of the min and max bolt diameters that we could use. We've got a min and max number of bolts, and then we're applying some design rules and optimizing the bolt selection. And it's gave us a couple of options from our database of bolts. We've got option 1 here, which is 24 M5 bolts, 16 millimeters in length, and option 2 is 20 M6 bolts, 80 millimeters in length. Now we've got some calculated information down here that we can use to select the bolt that we want to use for our application. We've got the min thread engagement that's been calculated. We've also got some weight information, so that's been extracted from the assembly, and we've got the costs, and we've got a total cost of £4,500 there, for a set weight of 0.194 kilograms. Now, the second set, which was the M6 bolts and 20 of, a little bit more heavier. The set cost is a bit more expensive, but the total cost is slightly cheaper. Now, for this design, I'm going to say actually weight is the major requirement for this assembly. So I'm happy to take the hit on the cost to reduce the weight. So I'm going to select, close this window, select option 1. Then we've got a couple of options here. So we're going to create a bolt sheet, because typically in engineering companies, we like to save some data that stays with the solution, and we get some approvals. And this is an example of that. And then we're also going to preview the bolt assembly. So if I hit OK, I'm going to go away and add in the bolts and create me a bit of documentation. If I bring this over to the screen. So this is the bolt sheet. We've got some information on the solution and the bolts, nuts and washers that we've selected. And then it's done a length check to make sure that we've got the minimum thread engagement, and that's a pass, and we can get some approval signatures on that if we need to, and save that with the solution. And then we've also added in a preview of the bolts. Now if we look at cutaway of this, you can see we've got no hole in there at the moment. So the next step is to add in that hole. So I'm going to do that by selecting the hole calculator. We've got an extra drop down menu here, so I'm going to select the hole calculator for this. And what this is going to do is add in the correct hole for that bolt that we've selected. I'm going to select the bolt. I'm going to select the bolted bodies. I'm going to select the bolt. And then we've got some toggles here to say, do we apply that to all positions? And do we want to add some PMI to the model? I'm going to hit OK. And again, it's going through and searching some spec databases, applying some design rules, and adding in the holes to the components. So we've got some information here of what it's doing. So selecting, searching spec database, applying some design roles. It's worked out what the clearance hole needs to be. And it's worked out what the the close clearance hole and the normal clearance hole. It's also calculated position tolerance. And then because we said we want to add some PMI, it's added some PMI. So let's have a look what that looks like. If I click this section again, we've got the hole that's been added to both components, and that's been added at all locations. As you can see there. If we go into the component, you can see we've added some PMI into here to define the hole. So that was the end of the demo. And I'm going to explain a bit more around the benefits. So that seems pretty simple. But imagine if you were to do that manually. Think of all the standards, specifications that you need to do the end-to-end process for that design. So you've got to look at drafting standards, assembly procedures, material specs, bulk specs, and we've also added a bit of cost into there, and that's typically not added into the process, and we have to think about that at the end. Where was that data stored? Traditionally in text files, spreadsheets, and brains, as we mentioned before. And you're probably going to have to do that a few times because you need to get checks and approvals for any of these designs to make sure that they meet the requirements. And what if there's a design change? You're going to have to repeat that over again. So being able to automate that process takes away a lot of that manual work that you would traditionally done. And the benefits are listed here, but essentially it's time saving. So we're automating things to save time out of the process, so the designers can focus on more of the value-added tasks that really distinguish your products against the competition and add real value. And I've highlighted design for cost in there. If we can start designing for cost earlier in the process instead of retrospectively going back and trying to take cost out of the design, that's where we can really add some benefits. So are you as a company ready for digital transformation? So you need to ask yourself, do we have well-defined design processes, scattered data and knowledge in text files and spreadsheets and in experienced engineers' heads? Do you have cost, quality, and efficiency KPIs that you need to meet? And a desire to standardize and improve the processes within your company and get better and more efficient at designing your products, then contact us. We've got some details here. These will be added to the links in the video. And I just wanted to touch on this slide again. So companies will be at different stages of digital transformation. So whether you're right at the start where you've got a load of data, you don't really know where it is, you've not really mapped out your end-to-end process and what design specs and standards and rules you need to use to design your products, or you might be at the other end where you've already digitalized a lot of your data, but you really want to get the best out of that, maybe use a bit of machine learning and AI to get some better insights into your data and improve a little bit further. We're here to help at any of these stages. And also it's worth saying that you don't have to do this in one hit. So you can identify key features or design decisions that take a lot of time, are very repeatable, and you can focus on a little proof of concept that will do that and go through the whole end-to-end process from discovery to enabling AI and deliver value for your company at a fast pace. So if you want to give us a call, like I said, the details are in the links in this video. We look forward to hearing from you, and thanks for listening to this today.